welcome friends, welcome to the lecture series of analog electronics. We are starting our topic with the differential amplifier, and that is base of the analog electronics and how does different analog equipments works. So for that purpose, I have shared previously the two videos of transistor circuits, right? So transistor circuits is basically the base of this differential amplifier, and in this differential amplifier, how it can be working, what kind of configuration over there. So basically two different types of C amplifiers are joined together and the differential amplifier can be formed. So in this session of this analog electronics, we are more concerned about the things that right now we are going to discuss, that is introduction, block diagram, differential gain and common mode gain. So basics of this differential amplifier will be starting from this section. So first of all, for the introduction, I must say that the differential amplifier, name itself suggests that it will amplify the difference between the two configurations. That means there will be two CE amplifiers. Yes, whatever up till you all have learned that CE amplifier works on different things, like common emitter is the basic idea of the CE amplifier, and we are earthing the emitter on both the sides, input as well as on the output side. So right now we will go into that section, but what is the need of the differential amplifier is that it is used for many physical measurements where responses from DC to many megahertz is required. That means some kind of input frequency over there, but if we need that signal in the large amount, or we can say in the amplified amount, then we can do this by the differential amplifier. And it is also the basic input stage of an integrated amplifier. We can say that it is also called as the integrated amplifier also. Here is the basic idea, and here is the block diagram of the differential amplifier, and likewise this all things can be understood. So differential amplifier is basically nothing but the two input signals over there, and it will be amplifying the difference between these two signals. So we can say that VD is equals to V1 minus V2. Likewise, here I have mentioned these things. The output signal in a differential amplifier is proportional to the difference between the two input signals. Right now you are more concerned about that particular figure. So we will see that things in just a minute. But before some analogies, we have to understood that how it can be understood. The output signal, the output voltage will be denoted as VO proportional to V1 minus V2. That we have already discussed up till now. That is, the differential amplifier is amplifying the difference between both the input signals. So that is the basic concept, and from that concept what we are going to discuss, that is our gain. What kind of gain over there? There are two types of gain. That is, one is differential gain and second is common mode gain. So differential gain can be denoted likewise, that is VO equals to AD into V1 minus V2. So for the sake of understanding, what do we exactly mean by the AD? Or sometimes they will say that the AVO, that is also okay. The denotations are different, but the thing is same, or the concept is same. That is the constant of proportionality, we can say that. But more oftenly we can say that the differential gain of the differential amplifier, that is AD, is denoted like this way, or we can say AVD or AVO. Different books will have their different annotations. So that's okay. But basic idea is that is differential gain. That is, if we apply two different inputs. If you remember the CE amplifier, in the CE amplifier, what we are doing, that any kind of one input will be there. You can say that CE amplifier, that is configuration for the betterment or remembrance. I have previously shared that video, and you can be able to understood now that for that video we have seen that there will be some input signal and there will be some output signal, and the input signal will be in the amplified form at the output terminals. So that was the basic idea, and from that basic idea, what we are doing right now, that is, we are using two different inputs, and we are amplifying the difference between both the inputs. So that is the concept, and this is called as the differential gain, and differential gain can be found out by VO divided by VD. VD means what? So that is difference of two voltages, V1 minus V2. Clear? So one more gain, that is common mode gain. Common mode gain is the average of both the input signals. Common mode signal denoted as VC. We can say VC equals to V1 plus V2 divided by 2. Here is an average of that particular input signals. Hence the differential amplifier also produces the output voltage proportional to common mode signal. So same formula for the previous and same formula for this common mode gain. What the thing is, that is common mode gain have average of both the inputs, and differential gain have both the inputs difference of the both the inputs. So this is the idea, and this is the basic understanding between the common mode gain and differential gain. And we can apply the constant of proportionality likewise, that is AC, and for that AC we can say that is our common mode gain. Hence the total output of any differential amplifier can be given as VO is equals to AD into VD plus AC into VC. Both the combinations are represented at the output terminals. So right now, after learning this all things, we are going into the section of that configuration. What kind of configurations that we are supposed to do for this kind of terminologies, or for this kind of concept of differential amplifier. Why I am discussing all these things, that is for the understanding of the operational amplifier. We are going to study the operational amplifier in the next videos, but first of all we need to know that how a operational amplifier can be formed and how two inputs are there. That all things can be described in this particular section. So this is the configurations. These are the different configurations of differential amplifier: dual input balanced output amplifier, dual input unbalanced output differential amplifier, single input balanced output differential amplifier, single input unbalanced output differential amplifier. Out of this four configuration, the dual input balanced output is the basic differential amplifier configuration. So from this sentence we can understood that the op-amp will be around this particular idea and nothing else, right? So this is the basic configuration. See what we are doing, that is, we have understood that only one amplifier is over here and second amplifier is over here. You can see that if you part this circuit in two different sections, then you can be able to understand that there are two different amplifier circuits. First you analyze this particular section only, and after you can analyze this particular section only, so you can be able to understand that two different CE amplifiers are used over here, and two different inputs are required for this circuit. So for these two different amplifier circuits, what it will do, then it will be using the difference between both these circuits, and common VCC voltages are applied over here, as you can see. So this is the basic idea, and likewise there are four types of this differential amplifier. Right now you don't need to bother about these things, but first, if we want to learn the operational amplifier, then we must know that how a differential amplifier will work, and after that we can say that this is my operational amplifier, and this way it will be working, right? So this is the dual input balanced output differential amplifier. There are two inputs, so that's why the dual input and balanced output, because we are using the VCC voltages for the same, and here we are taking the difference between this. So this is called as the balanced, and in the next configuration you are knowing this, that we are using only one input only. So this is not called as the balanced, this is called as unbalanced. See, there is only one voltages we are taking, that's why we can say that only one amplifier configuration we are considering over here. So this is the one idea. Now secondly, this is called as the single input. Here you can say that we don't have applied any kind of dual inputs. Only one input is there and the output is here. Okay. So this is the basic idea, and single input balance output differential amplifier will be working in this way. So this way we can say that the differential amplifier will work. After that, single input unbalanced output differential amplifier is over here. So after that you can say, so you can switch over likewise, that first we will take at the first input, and then after we will taking as the second input. So this is the basic idea, and differential amplifier will work this way. So basically what we are doing, that input voltages are taken over here, and this input voltages of any particular one CE amplifier will be applied. So it is called as the unbalanced output. So this is the basic concept, and I hope that all of you getting this things of differential amplifier. So I end my session over here, and if you like my video, then you can share and subscribe my channel. Thanks for watching. We will see the next operational amplifier things in the next lecture. Thank you.